Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 224, Basic Calculator. Given a string s representing a valid expression, implement a basic calculator to evaluate it, and return the result of the expression. Note, you are not allowed to use any built-in function which evaluates strings as mathematical expressions, such as eval. If you haven't already seen my video on Basic Calculator 2, which is actually a simpler version of this problem, go watch that one first, because it's going to be the same approach that we want to use to solve this question that we used in the other one. The main differences between this problem and Basic Calculator 2 is that we, in this case, only have pluses and minuses, but we do have the case where we have to deal with parentheses. In the previous one, we had plus, minus, multiplication, and division. In this case, it's just plus and minus and parentheses. Basic Calculator 3 will actually be plus, minus, multiply, and divide, and parentheses, but for now we're just solving it where it's plus or minus, so that kind of makes our lives a little bit easier. So let's go over one of these basic examples here. If we're given this string s, then obviously 2 minus 1 is going to be 1, plus 2, that's going to be 3, so that's how they got that answer. And then for this one, as we can see, it's a little bit more complicated. Obviously, we need to respect the order of operations, so we do whatever's in parentheses first, and we go as far into the nested parentheses as we can. So as we can see here, this is the furthest nesting, so we would add this part up. So 4 plus 5 plus 2, that's going to be 11, and then we add 1 and subtract 3, so that's going to be 9, and then this part is 14, so we add 9 and 14, and then we get 23, which is the answer that we expect. So, an easy way to do this would be like to find out the nested parentheses, add them up, and then go back and do that. But that's going to be a more complex solution because we have to make multiple iterations through our string here. And, it could potentially be worse than a big O of n runtime. And we want to maintain the same runtime as we did for Basic Calculator 2, because it was actually the best we could do there. We want to make one pass through the string, which means that, we're going to go from left to right. So let's take a step back and think about how we might actually do that. Okay, so I told you that we want to solve this problem in basically a linear time where we just go through the string from left to right in one pass and not do anything extra. So how might we do that? Because we have to deal with the parentheses, and that's going to make things tricky. Well, what we're going to do is actually, we can think of when we see a left parenthesis as it kicking off like another iteration of our function here to just process whatever's inside. So we can think of it as kind of like a recursive call where we want to get the result of whatever's inside the parenthesis and then add it back to whatever was outside. So to do this, we're going to make use of basically a variable to track whatever the current state of our calculation is when we enter a new, nested parenthesis. So, we'll track in this data structure basically the current result and the current sign that we're working with, right? Because when we finish processing this and we come out and we see that, okay, this is 11, we need to know whether to subtract 11 from whatever the previous result was or to add it, right? And that's what the sign will be. So it's basically just going to tell us what the sign is. And then this 1, we can think of it being as like the previous result. So we know what to add, 11 to when we finish computing, and then we can continue from left to right. So that might be a bit confusing. And let's kind of walk through this and go from left to right and see how we might solve this. So I told you that we need to keep track of the current value. So we're going to set that equal to 0. And we're going to say that the result is also going to be equal to 0. This is going to be our final kind of answer here. And then we need to keep track of the sign, which is going to tell us, whether the previous operation was a plus or it was a minus. And we're going to use a 1 to indicate that it was a plus, and then the negative 1 to indicate that it was a negative number. It was a subtraction. So we're just going to say 1 because we start with a positive, and we're going to need that data structure to basically hold, the state. So we'll just call it a stack, and we'll say, it's just going to be an empty list. So we want to go from left to right. And what we do when we see a left parenthesis is actually we're going to save the state of our calculation into this stack here. And like I said, the first thing is going to be the res. So the current result is 0 and the current sign is going to be 1. So that means that when we process whatever is inside of this parenthesis, we want to add it to basically 0. And that makes sense, right? The first thing that we'd process, like in this case, we'd just add 0 with 2, and that's how we'd get that first value of 2. So that's going to be what our stack looks like. And then we want to reset our res, because we can think of, going into a parenthesis as starting like a new invocation of our basic calculator. We can almost think of it as like a recursive call, but we're going to do this iteratively. So res is going to be reset to 0. And then obviously cur is still 0, and then sine is still 0 now that we've entered this. So what we want to do is now we're going to start processing from left to right. So we see this 1, we process it, and we simply say that cur now is going to be equal to 1. So we're going to say cur equals to 1, and the sign is still 1. So we keep going. So we get to a plus, and whenever we see an operation, we basically need to apply the current value with whatever we want to add that number, because like once we get to a plus here, that means that we've parsed out a number completely, so we need to apply that number that we just parsed to whatever the previous operation was. So you can do this either once you fully parse it or once you get to the next operand. It doesn't really matter. We're just going to do it that when we encounter a plus or a minus, then we're going to apply whatever the last number was previously. Either way works. I'm just going to do it this way. So now that we see a plus, we need to add our 1 to our result, because our sign is 1. So we're going to say res is now going to be equal to 1, and we're going to continue. Oops. So now we see another parenthesis. So remember, we need to save the state of our current operation once we see this parenthesis. So our stack is still going to have 0, 1. And now we need to save the current result, which is 1, and our sign is still 1. Cool. And now we reset res to 0, because we can think of this as being like its own fresh computation. And now current is still gonna get reset to 0 here as well, because we haven't parsed anything. So now we're parsing this 4 plus 5 plus 2. So we see the 4, so that means that current is going to be equal to 4. And then we get to the plus, which means that we need to apply our last operation and the last number, so 4. So now result is going to become 4, because 0 plus 4, 4. And then we get to this 5, so now our current is going to be 5. Then we get to the plus, we need to apply the previous operation, so 5 plus 4. So now res is going to be 9. And then we get to the 2, and we need to basically store that into our current, so it's going to become equal to 2. And then we hit this left parenthesis. So, this right parenthesis. That means that we finished processing whatever was in here. And now what we need to do is simply, take care of that last number that we processed. And then we need to, deal with our stack. So we have our 2, so we're going to add that to our result. So now we have 11. And what we want to do now is we want to say, remember that if we pop from the stack, then, that's going to tell us the sign that we need to apply to this number that we got. And then this second pop will tell us the previous number that we got. So if we pop from the stack, we'll get a 1, which means that we want to add our value. So we're just going to keep it as 11, because 11 times 1 is going to be 11. So we're going to keep the same value. And then the previous number that we pop is going to be the actual previous result that we had before entering this nested parenthesis. So we're going to have 1 plus 11. So that means that our current result is now going to be equal to 12. And we're going to reset cur equals to 0. Now we get to this, left parenthesis. We exited it. And now what we want to do is, we get to this left. So now we need to actually, I think this point is where you would add the 11 and the 1. Apologies for that. Res is now 12. Cur is 0. So now we get to the 3. So cur is now going to be equal to 3. Then we hit another right parenthesis, which means that we need to again pop from the stack. So we can see, so this is going to be gone from the stack. So it's going to be 0 and 1. So that means that, our previous sign was 1, which means that we want to keep our, current value as basically 3. And then what we're going to do is we're going to add our current result. Apologies. We need to do the subtraction first. So we're going to say 12 minus 3 is going to be 9. And then we need to add that to whatever the previous result was. So 0 plus, oops, you can't see that. Let's see where I can go. So it'd be like 0 plus 9. We'd have 9 now. And now our stack is empty. And then we get into this part here. So we're going to add you know, 0 and 9. So this is what would happen when we get to this plus. And then we're starting off a new basically stack here. So we can think of our stack now. Okay, so what's the previous result? It's 9, and we want to be adding. So we're going to say 1 here, and then we're going to process whatever's in here. So that means that the current, okay, this is getting messy. So the current is going to be 6. Then we get to this. We're going to add that to our result. So res is going to be 6. Then we get to the 8. And then what we want to do when we hit this left parenthesis is basically add that to our res. So now we'll have 14. And now that we hit the right parenthesis, we need to basically apply this 14 to whatever the previous result was. So we look at the sign. So it's going to be 1. So that means that 14 times 1, obviously still 14. And we will need to add this number to whatever our previous result was. So 14 plus 9 equals to 23. So that's how we want to solve it conceptually. It is really messy to write out, and I apologize. It's one of those questions where the code makes a lot more sense than actually drawing it out because it's just so messy to do. But I think let's go to the actual code editor and we will walk through it line by line, and hopefully it should make a whole lot more sense. I think the code is really clean, and it makes a lot more sense than this drawing here, which can be a little bit confusing. So let's go to the code editor and we'll write the code. And like I said, it's going to be basically the same algorithm that we use for basic calculator 2. So I'll see you there. We're in the code editor and it's time to write the code. So remember that we need a few variables to track our result so far. So remember, we need the current result, the current number we're working with, the current result, and we're going to initialize those to be 0 in the beginning. And we need the sign of the operation that we're working with. So it's going to be 1 for a plus, and then -1 for obviously a subtraction. And we also need that stack variable to basically keep track of whatever our current operation was before we went into kind of a nested parenthesis. So that way when we come out of it, we can apply it retroactively to whatever was occurring previously. So what we want to do is we want to iterate through our string from left to right. So we're going to say for char in S. We're going to say if we're at a digit. So if char dot is digit, then what we want to do is basically add that to our current value. Again, unfortunately, we don't have just digits. They can be something like 334, 32, even bigger numbers. So we need to process all of it. It'd be nice if it was just digits, but that's not the case. So we'll say that the current value equals cur times 10 plus integer of whatever the current character is. Otherwise, if we have a mathematical operation, then we need to handle that. So we're going to say if the current character is either a plus or it's a minus, then what we need to do is apply the computation of the previous value. So we're going to say res plus equals to sine times whatever the current value is. And the reason that we do it here is, it's just a personal preference. You can either apply the, sine times the current at the end of parsing your digit, but that way you will actually need to just do it with an index-based approach. This way we can just use the for char and S. Otherwise, you'd need to use a while loop. It doesn't really matter. You'll get the same answer in the end. This kind of just makes it simpler, so you don't have to keep extracting the value each time and worrying about index errors. So we're going to apply the computation if we hit a plus or a minus, because that means that we finished processing whatever the previous value was, and it should be contained in our current variable here. And we need to basically reset the sign now. So we're going to say sign equals 1 if char equals to a plus. Otherwise, it's going to be a minus, so it needs to be a -1. And then we need to reset our current value to 0, because now we're going to be starting with a fresh number at whatever the next value in, the next character in S is. Otherwise, what's going to happen is if we have a left parenthesis, then remember that we need to basically keep track of our current state in that stack. So we're going to say stack.append, and we're going to put in the result first. So whatever we currently have as our result, we're going to put it in there. And we're going to say stack.append, and we're going to put in the current sign that we work with. So that way when we come out of the parentheses, we need to apply that result, add it or subtract it to whatever the previous result was. So we're going to reset the sign to be 1 because we can think of it as like starting a new calculate function on the inside of this. So we're going to reset it equal to 1 because that was what our original state was. And we need to reset our result to be equal to 0 because we can think of it as starting fresh. Otherwise, if we hit a right parenthesis, that means that we've closed one of our left parentheses, and that way we need to apply whatever our current value is, and we need to add it to whatever the previous was. So what we're gonna do is first we need to actually parse out whatever the last number was, because we actually need to do it, because remember we apply the addition and subtraction at the point that we see a plus or minus, but obviously if we see a right parenthesis, we won't actually see it, so we won't have taken care of that last number that we parse. So that's why we need to do it now. So we're going to say sign times cur, which basically the same thing that we did up there. And then what we want to do now is to our result, we essentially want to multiply it by whatever the sign was previously. So remember, we put the sign in last. So since it's a stack, right, it's going to be last in, first out. So we're going to get the sign out. So we're going to multiply it by whatever's at the top of the stack, which is going to represent the sign of whatever it was before we entered the parenthesis. And then what we're going to do is we're going to add to res whatever is now at the top of the stack, which will be our previous result. So that's the reason why we use the stack, because we can easily keep track of whatever the previous sign was and the previous result was. So we can think of it as being this plus and then whatever the expression was before that. And then we need to reset our current to be 0 because now we've finished processing. And the last case here in our else is actually going to be the case where we have a white space, but we don't want to do anything there. We just want to ignore it and continue. So that's going to be processing the string from left to right. And then at the end, we simply need to do a little bit of processing. So we're going to say return res plus the sign times the current value. So this is going to be handling any values that are left over in our calculation. We want to basically handle it at the end if there's anything still left in our current that we haven't done. Because remember, we apply the the additions when we see a plus, but obviously for something like this 2, we would never see a plus after it if it's the end of the string, so you would never add it. And since we do the addition or subtraction when we see a plus or minus, that's why at the end, in the case here, where there is nothing after it, obviously this wouldn't be a valid expression if there was like a plus here. Then we would simply just need to handle that remaining cur. So that's the reason why we have res plus sign times cur. Some people have solved this question as like they add just a plus to the end, but I mean technically I think in Python you can concatenate to an end of a string in constant time. If you're doing this in another language, that probably won't work because first of all, in most languages strings aren't immutable, so you can't do that. In Python they are, and I think you can append to a string in constant time, but don't quote me on that. So that's the reason why we need to take care of this. Anyway, let's submit this, make sure we haven't made any bugs, and we see that it works. Okay, so let's think about the time and space complexity here. So the time is going to be the exact same as basic calculator 2, where we're just going from left to right on our string and we're processing each element once, so it's going to be a big O of n solution. So space complexity wise, well, in the worst case, what is our space complexity going to be? Well, obviously these variables here are going to be constant space allocations, so we don't have to worry about that. But this stack here, it does hold some elements, but is it going to hold that many? Let's think about this. I guess what would be the worst case here? We can't say that this is going to be a constant space solution because we don't know how many items are going to be in our stack at any one point. So I think this is going to be big O of n because our stack could end up holding a lot of elements if in the worst case that we have like a super nested expression here. So something like super nested, we would need to keep track of like all of those states, and obviously that is going to be dependent on how long s is and how complex it is. So I think it's going to be a big O of n on the space just because of that stack. I don't think we can do this in constant time, although perhaps you can do it. Like maybe the stack doesn't count as big O of n space, because technically we're not storing the entirety of the string. I would need to kind of think about that one. But I believe for the time for sure is big O of n. The space is, I think, most likely big O of n, or, even better, it could potentially be big O of 1, so constant space. But I would lean towards big O of n because we don't know how big this stack is going to get. So that's going to be how you solve this problem. Really similar approach to the way we solve basic calculator 2. Obviously, it is a little bit more simple in that we don't have to deal with multiplication or division, although in this case we have to deal with left and right parentheses, which is a bit annoying. I think basic calculator 3 will be a combination of the first two, where we have to deal with all the mathematical expressions and we have to deal with left and right parentheses. So I'll have that video out quite soon. And yeah, so that's how you solve this question. Hopefully you enjoyed this video. If you did, please leave a like, comment, subscribe to the channel. If there's any videos or topics you'd like me to make, please leave them in the comment section below. I'll be happy to get back to you guys with those videos. Just let me know what you want to see. And otherwise, thanks for watching and have a nice day. Bye.